Elementary Science Class 7. Physical and Chemical Changes. Physical changes. In this activity, we're going to explore different types of physical changes.
Okay, what are physical changes?
Physical changes are changes in the physical properties of a substance, such as shape, size, color, or state, without the formation of a new substance.
I see. Can you give me some examples?
Sure, let's start with cutting a piece of paper into smaller pieces. Even though the paper is now in smaller pieces, its chemical composition remains the same.
Interesting, so the paper hasn't changed, just its physical form.
Exactly. Now, let's try crushing chalk into dust and then adding water to make a new piece of chalk. We're just changing the physical state of the chalk, not its chemical composition.
Wow, that's really cool. What about changes in the state of water?
Great question. When we melt ice and then freeze the water again, we're seeing a change in the state of water from solid to liquid and back to solid. But the chemical composition remains the same.
I understand now. And what about the change in color of the heated metal blade?
Yes, that's another example of a physical change. The color change of the metal blade is due to a change in its physical properties, but the underlying chemical composition remains the same. Chemical changes. Have you ever noticed how iron can change over time when left exposed to the atmosphere?
Yes, I've seen iron gates and tools get that brownish coating on them. What is that?
That brownish substance is called rust, and the process is called rusting. Rust is a different substance from the original iron.
Wow, I didn't know that. So, is rusting an example of a chemical change?
Exactly. Chemical changes are when new substances are formed, and rusting is a great example of that.
Okay, can you give me another example of a chemical change?
Sure, let's look at what happens when you burn a piece of magnesium. The magnesium ribbon burns with a brilliant white light, and it leaves behind a powdery ash.
Interesting. So, the ash is a new substance formed during the burning process.
Yes, that's right. The chemical equation shows that the magnesium reacts with oxygen to form magnesium oxide, which is the ash.
Fascinating. And what happens if you mix the magnesium oxide with water?
When you mix the magnesium oxide with water, it forms a new substance called magnesium hydroxide, which is a base. In a chemical change, one or more new substances are formed. For example, when we mix vinegar, acetic acid, and baking soda, sodium bicarbonate, they react to produce carbon dioxide and other substances.
Wow, that's fascinating. And what happens when we pass the carbon dioxide through the lime water?
When carbon dioxide is passed through lime water, it reacts to form calcium carbonate, which makes the lime water turn milky. This is a standard test to detect the presence of carbon dioxide.
I see. So chemical changes can be identified by the formation of new substances, as well as other changes like color, heat, or sound.
Exactly. Chemical changes are very important in our lives, as they are responsible for many processes, from digestion to the production of new materials like plastics and medicines. Rusting of iron. Rusting is a chemical reaction that happens when iron comes in contact with oxygen and water. It can slowly destroy iron particles over time.
Wow, that's interesting. How does the rusting process work?
The rusting process can be represented by the equation iron Fe plus oxygen, O2, plus water, H2O, rust, iron oxide Fe2O3.
I see. So, the presence of both oxygen and water is essential for rusting to occur?
Exactly. And if the air has high moisture content, or humidity, the rusting process happens faster.
That's good to know. What can we do to prevent rusting?
One way is to apply a coat of paint or grease to the iron surface, which can prevent it from coming into contact with oxygen and water.
I see. And what about other methods?
Another way is to deposit a layer of a metal like chromium or zinc on the iron, a process called galvanization. This helps protect the iron from rusting. Crystallization. Crystallization is the process of forming large, pure crystals from a solution. It's an example of a physical change.
How does it work?
Well, you can see the process in action by adding copper sulfate powder to boiling water with a few drops of dilute sulfuric acid.
Wow, that's interesting. What happens next?
As you continue to add the copper sulfate powder and stir the solution, it will eventually become saturated. Then, when you allow the solution to cool without disturbing it, you'll see the copper sulfate crystals form.
That's really cool. Why is crystallization important?
Crystallization is important because it allows us to obtain pure substances from their solutions. The crystals formed have a clear, defined shape, unlike the salt obtained by evaporating seawater.
I see. So it's a way to get pure, well-defined crystals of a substance.
Exactly. Crystallization is a valuable process in many industries, from pharmaceuticals to electronics.